What if one of the most valuable green hydrogen projects in the United States never actually became a hydrogen project at all? What if the infrastructure built to produce clean fuel ended up being more valuable to artificial intelligence than to the energy transition itself? That is exactly what just happened, and it reveals a deeper shift in how energy systems are evolving in 2026, one that most people haven't fully understood yet. Plug Power had been developing a site known as Project Gateway in New York. This wasn't just another early-stage concept or a speculative hydrogen idea. This was a real physical industrial asset. Land had been secured. Grid connections had been negotiated. Substation infrastructure had been put in place. Power access, arguably the most difficult part of building a green hydrogen project, was already solved. In the world of hydrogen development, this is what separates PowerPoint from reality. And yet, instead of producing hydrogen, the site was sold. The buyer was Stream Data Centers, a company focused on building hyperscale infrastructure to support the rapid expansion of artificial intelligence and cloud computing. The deal was valued at approximately $132.5 million, with potential upside pushing it closer to $142 million. But the number itself is only part of the story. This transaction sits inside a broader strategy by Plug Power to unlock roughly $275 million in liquidity through asset optimization, cost reduction, and capital restructuring. This is not just a sale, it is a signal. Because what was actually sold here was not simply land, it was access to electricity. Project Gateway had something that is becoming increasingly rare: pre-secured, high-capacity electrical infrastructure. That includes grid interconnection rights, substation readiness, and the ability to deliver large amounts of power to a single site. For hydrogen, this is essential. Electrolyzers convert electricity into hydrogen, and without reliable, large-scale power, the economics simply don't work. But here is where the story takes a turn. That same infrastructure is even more valuable to data centers. Artificial intelligence has created an unprecedented surge in electricity demand. Training models, running inference workloads, and maintaining global uptime requires constant, uninterrupted power. These are not intermittent systems. They do not wait for wind or solar availability. They operate continuously. And that means they need access to stable, high-density energy immediately. So when a data center developer looks at a site like Project Gateway, they are not evaluating hydrogen potential. They are evaluating power readiness. And in a constrained grid environment, a site that already has power access is far more valuable than one that doesn't. This is the hidden competition that is now emerging between hydrogen and AI. Hydrogen depends on electricity to exist. AI depends on electricity to scale. But electricity itself is no longer abundant in the way it once seemed. In many regions, grid capacity is fully allocated. New projects, whether they are hydrogen plants, factories, or data centers, are facing delays not because of lack of funding, but because of lack of power. And in that environment, whoever can monetize electricity faster tends to win. Plug Power's decision reflects that reality. The company is effectively converting a long-term hydrogen development asset into immediate liquidity by selling it to a buyer that can deploy it faster and generate returns sooner. From a financial perspective, this is rational. Hydrogen projects take time. They require offtake agreements, regulatory alignment, subsidy frameworks, and stable electricity pricing. Data centers, by contrast, are backed by immediate demand and rapid deployment cycles. But this is where the deeper system story begins. Because when a hydrogen-ready site is sold to an AI data center, it raises a fundamental question. Is hydrogen competing with AI for infrastructure? And the answer increasingly is yes. Both systems require the same foundational inputs: land, power, permitting, and capital. But they operate on different timelines. AI is scaling now. Hydrogen is still building toward scale. That timing difference creates a structural imbalance. Infrastructure that might have been used for hydrogen 5 years from now is being absorbed by AI today. This is not a theoretical issue. It is happening in real time. Plug Power's broader strategy underscores this shift. The company has been under pressure to improve liquidity and optimize its cost structure. Hydrogen, despite its long-term potential, is capital-intensive and sensitive to external variables. Electricity pricing alone can determine whether a project is viable or not. And when those economics become uncertain, companies look for ways to stabilize their position. Selling infrastructure becomes one of those ways. But this also reveals something critical about where value is moving in the energy system. The value is not just in producing energy, it is in controlling access to energy. Project Gateway had already solved one of the hardest problems in energy development: securing power. That alone made it valuable, regardless of whether it was used for hydrogen or AI. And in today's market, where electricity demand is surging and grid expansion is lagging, that kind of asset becomes highly liquid. So what we are seeing is not just a transaction, it is a reallocation of energy infrastructure, from hydrogen to AI. And that has implications far beyond this single deal. Because if this trend continues, hydrogen developers may find themselves competing not just on cost per kilogram, but on access to electricity itself. And that changes the entire equation. It shifts the bottleneck from technology to infrastructure, from electrolyzers to grid connections, from innovation to execution. This is where most hydrogen narratives fall short. They focus on efficiency improvements, cost reductions, and scaling potential. But they often overlook the system-level constraints that determine whether a project can actually be built. And right now, one of the biggest constraints is electricity availability. AI is accelerating that constraint. Data centers are expanding globally, and they are doing so at a pace that outstrips grid development. In some regions, utilities are already struggling to keep up with demand. New interconnection requests are being delayed. Transmission upgrades are taking years. And in that environment, pre-existing infrastructure becomes a premium asset. That is exactly what Plug Power sold, and that is why this story matters, because it reveals a deeper shift in how energy systems are being prioritized. It shows that the immediate demand for computation is reshaping the allocation of physical infrastructure, and it highlights a tension that will define the next decade of energy development. The tension between fuel and power. Hydrogen represents stored energy. It is a way to decarbonize sectors that cannot easily electrify, but it requires upfront energy input to produce. AI represents real-time energy consumption. It requires continuous power to function. And when both systems compete for the same input, electricity, the one with faster returns tends to dominate, at least in the short term. But this does not mean hydrogen loses. In fact, there is a scenario where these two systems converge. Data centers could eventually use hydrogen as a form of backup or even primary power. Fuel cells could provide stable, on-site energy that complements grid supply. In that scenario, hydrogen becomes part of the AI energy stack, rather than a competitor to it. But we are not there yet. Right now, the system is still fragmenting. Infrastructure is being allocated based on immediate demand, not long-term integration. And that means decisions like this one, selling a hydrogen site to a data center, are likely to become more common. Which brings us back to Plug Power. The company is not abandoning hydrogen. It is adapting to a system that is evolving faster than expected. By unlocking capital from infrastructure assets, it can focus on areas where it sees more immediate opportunity or better alignment with its strategy. But the fact that this adaptation involves selling energy infrastructure tells you everything you need to know about where the pressure is. The pressure is not on technology, it is on the system. And if you want to understand where hydrogen is going, you have to follow that pressure. Because that is where the real story is. And if you're serious about understanding how these systems actually work, how hydrogen projects get built, financed, and scaled in the real world, this is exactly what we break down inside H2 Hub by Renee Energy. It is not about headlines, it is about execution. The link is in the description. Because the future of hydrogen will not be decided by announcements. It will be decided by who controls the system.